Welcome back to Ready Controls. If you're passionate about automation and control systems, you have come to the right place. Today, we are kicking off a brand new playlist focused on practical application of basics we covered in our previous videos. Have you ever wondered how factories efficiently sort and count thousands of packages every day? Today, we'll show you how to program a PLC to automate the conveyor belt sorting system, ensuring precision and efficiency in industrial process. Our objective here today is to create a ladder logic program to automate a conveyor belt system that sorts packages into two bins based on their weight and counts the number of packages in two bins. So what we are talking about here, I used draw.io to come up with a simple visualization. What you see here is a conveyor belt. This is that conveyor belt. It's a motorized driven conveyor belt with motor number M1, and this belt goes from left to right, and you have a box moving on this belt. Right here is where we have a weigh scale. It's an industrial weigh scale which weighs the box weight and gives the PLC a signal if the weight is okay or not okay. And once the box moves to this location, if it's a good part, that means if the weight is in tolerance or it's good, the diverter will kick the box into the good parts lane but if the weight is out of tolerance, the diverter 1 will be retracted in the back position, and then diverter 2 kicks it and the part ends up in the bad parts lane. We have a bunch of photo eyes here. These are photoelectric sensors that will pick up the presence of a box. We have photo eye 1 here, photo eye 2 for box at the weigh scale, 3 is box is in front of diverter 1, 4 is box in front of diverter 4, 5 is box is at the end of the good parts lane, 6 is box is at the end of bad parts lane. Okay. So that's the layout. Again, it's a simple conveyor, and our objective is to write a program so that when the box is in tolerance, it goes to the good parts lane. When the box is out of tolerance for the weight, it goes into the bad parts lane. And we should also count how many good parts we are making in a particular day, or we just need to count how many good parts and bad parts in that one run. Okay, that's our target. So before we go ahead and start programming, the best practice is to write down all our input and outputs that we're going to use in the program. So I will put them side by side so we could see how we came up with this one. Okay, so I took the layout of the machine and I just broke down like what inputs are we going to use and what outputs are we going to use. For the motor 1 M1, we're going to use a run command for the motor. That's an output type, and we're going to use a output 0 in our PLC chassis. Our PLC we're going to use is a Compact Logics PLC with embedded IO, and our assumption is 1 is the motor gets a run command, 0 means the motor gets a stop command, and diverter 1 DV1 is another output. We are going to use output 1 for extension of the diverter. Extend means the diverter is going to kick the box into the good parts. DV2 diverter 2 extend is for the bad parts, as you can see here. That's diverter 2. Okay, so I just put everything in one place so it's easy for us to reference. And then we have a signal from the weigh machine. That signal, for now we assume it's a hardwired signal coming from the weigh controller, saying like the weight is okay, and that's why to input data 5, and 1 is good, 0 is not good. And for this to simulate, we're going to use, I have a trainer, I don't have a weigh control here, so I use this selector switch 1 position as a signal from the weigh scale. That's what we are indicating here. And photo eye 1, 2, 3, 4, 5 and 6 as indicated in the diagram are memory tags in the PLC. We're just going to use them to do counting operation. Start button, we're going to use a start button, which is the green button here on the trainer. That's why to input data 0. Stop button is why it is the red button. That's why to input data 2. And then for in auto, machine in auto, I'm going to use selector switch 3 positions. The left and right right is for auto, which is why to input 8. Left is for manual, which is why to input 7. And for simulation, just to show the status of the cylinder, I'm going to, whenever diverter 1 is extended, we're going to turn the green light on, and whenever diverter 2, which is for bad parts, when that's extended, we're going to turn the blue light on, just for a simulation so we can see both in action. That's about the IO table. So this is crucial. The first thing we need to understand is the layout, and then the second thing is what are the inputs and outputs in play for this logic. And then we go, before going into the logic, we go and write down what are our assumptions. And since this is a basic video, we're going to use the motor is on a motor starter, and the weigh scale just sends a direct contact for a like a signal, 24 DC signal when weight is okay. For all practical purpose, to keep it simple, whenever that input from the weigh scale is not okay, that means whenever it's low, we consider it as bad part. When weight condition is not okay, the diverter 2 will turn on, which will kick the part to the bad lane, this one. When weight scale signal is good, then we use diverter 1 to kick it out. Both diverters are pneumatic. For simplicity, we are ignoring the reed switches and the type of solenoid valves, just to keep it very simple, right? Because it's our first basic programming. So the way how the sequence, how I'm planning to write this is use something called a sequence step. We use a step 0, and in that step all we are doing is checking for is everything in auto and cycle start. So that's all that step is going to do. So in that step we're going to check the inputs for if the cycle start push button is pressed or it's okay. Then we turn on the start light, turn on the buzzer for the start for indicating the machine is running, and then we index into step 10. And in step 10, what we are looking for is there are no boxes on the conveyor, which is nothing but in our assumptions. To make it simpler, we don't want to have any boxes anywhere in the machine, which is not practical, but just for a simplistic basic programming, our initial run condition is no cases on the conveyor. That means all my photo eyes are unblocked, they are not blocked. Okay, so we check for all the photo eyes to be unblocked. Once the photo eyes are all unblocked, we will index to step 20, and in step 20 we check for both the diverters to be in the retracted position as shown in the picture. They are fully retracted. So in step 20 we're going to turn the diverters. As we said, we have only one output for the diverter. We turn that output on, it's going to extend. If we turn that output off, it's going to retract. So we're going to turn the diverter extend output to low. That means it's retracted. Okay. Again, we said extend this output on, and when we turn this output off, it will retract. Okay, that's all we're trying. We're just making sure the initial conditions are all met. And then we go to step 30, and then we wait for a box being at station 1, which is photo I1. And in that step, we're waiting for the photo I blocked. And once the photo I is blocked, we're going to turn the motor 1 on. And then once the motor 1 is on, the box moves, and we wait for photo I2. So in step 40, we are waiting for the box to show up at photo I2. Once the box shows up at photo I2, we check for wait OK. No outputs to be turned on in that step. We're just waiting for way station to say OK or not OK. Again, since this is basic, we're going to just check for it, but in more advanced, we're going to trigger the weigh scale and ask the weigh scale to do a weigh check and give us a signal. But for now, we'll just check for the weight. And in step 50, we wait for the signal for the weigh scale. So when we are in step 40, we check for the weight signal, okay, not okay. We move to step 50. In step 40, we wait for photo I blocked. We move to step 50 and we wait for the signal from the weigh scale. Depending on the weigh scale signal, if the weigh scale says the weight is intolerance, that would be weight OK will be high. If weight OK is high, then we go to step 60. Okay. So if weight OK is high, we go to step 60. And in step 60, we're expecting the box to be in front of photo I3. And if the box shows up at photo I3, which is right in front of the diverter, we kick the diverter by using diverter 1 extend on, and then we wait for the box to show up here on photo I5. Photo I5 is blocked. Then we turn the diverter back. We retract the diverter back to its retract position, which is turning off the extend. And then we go to step 0 and wait for the cycle to start. But when we are in 50, if we got weight OK being low, then we go to step 80, which is to here. And in step 80, we are waiting for the photo I4, which is right in front of diverter 2, to be blocked. And then we extend the diverter 2 and we move to step 90, wait for the box to come to photo I6, which is here. And then we turn the diverter off and then go to step 0. So step 50 is where the decision making is happening, and this is where all the decision between whether the box would go to diverter 1 or 2 is going to happen. And these two are for good parts. These two are for good parts, and these two steps are for the bad parts. And this is the main decision step where we check for the signal from the weigh station. Again, step 0, what we wanted to do is check for everything is in auto. And step 10, we check for there are no boxes on the conveyor. And in step 20, we check for diverters are retracted. And 30 and 40 are we waiting for the box to be in the start position, and then we wait for the box to be in at the weigh station. And then 50 would be checking for the signal from weigh scale, and 60 and 70 are the good path, 80 and 90 are the bad path. And as you can see, 90 is always going to step 0 and 70 is always going to step 0. This is the best way to one of the best practice or good practice. There are many ways to write the PLC program, but in this way it's a lot easy to sit down with a mechanical engineer or a technician and write down the flow before we begin writing the logic. So with this in position, I think we completed the part 1 of this playlist, where we set up the IO table and we set up the logic. In part 2, we will begin the process of writing the actual code in Studio 5000. Please stay tuned for part 2. If you like this video, please share with your friends, and don't forget to subscribe and share any of your experiences. Thank you. See you in the next video.